Hello everybody, my name is Ikenna from Smiling Sun. Everything solar installation, everything inverter installation, everything going green. How you guys doing? Now I'm sure you have this thought in your mind and I'm sure you wonder sometimes, how does the battery charge? So if you have a solar system installed in your house to be able to give you energy, then chances are that you have a storage system, which is the battery. Okay, so the battery, you store energy in here and you get to use them later. It's important. Okay, so if you have solar panels on your roof, you trap the energy in here. Then when the sun goes down, you revert to the energy that you have stored in those batteries and voila, all your home is lit up. Okay, but sometimes you wonder, how exactly are these batteries charged? That's a very pertinent question for you to ask. If you have this knowledge, you'll be better disposed to taking care of your batteries, because if you take care of your batteries, woof, you'll be able to kick out a long service life out of those batteries. Okay, you'll be able to kick out more cycles because the batteries cost a lot of money. Okay, so if you take care of your batteries, you'll be able to use the battery a long time before you begin to wonder again. Woof. When next am I replacing my batteries? I'll be more than pleased to tell you guys how the batteries are charged. Are you ready for it? Grab your popcorns. Let's go! Stick around, I'll be right back. You're welcome back. It's still Ikenna, the usual suspect. Everything solar installation, everything inverter installation, everything going green. If you haven't subscribed, always remember, that's exactly how you support this work that we're doing. So if you haven't subscribed, we would love you to take your time to click on that subscription button. All right, don't forget to comment, don't forget to share, and do not forget to like. So how exactly does the batteries charge? Does it really store these energies? So let's find out. So to be able to make it very simple, because I need everybody to be able to understand this, we are going to group the batteries into three. All right, so we're going to segment the batteries into three sections. So we're going to have the lithium battery on one side. That leaves us with all the lead acid based batteries. I'm talking about Tubular, Gel, and AGM. Now, inside the lead acid based batteries, we're still going to further divide them into two. All right, so the tubular battery is going to be standing alone, and that gives us the second section. And the final third section, we're going to have the AGM and the gel all grouped in one place. So why exactly am I doing this? Somebody is asking. They are all solar deep cycle batteries, so why exactly are you segmenting them? Why not just explain to us how exactly it charges? Well, the reason is simple why I'm doing this, because the batteries do not all charge the same way. A lithium battery charges differently from a tubular battery. A tubular battery charges differently from an AGM and a gel battery. All right, so I will explain just in a couple of seconds so that you don't get confused. Like I said, it's not my intention to get you confused. All right, so let's start with the lithium battery. Now, the lithium battery goes through only 2 cycles of charge. You essentially have 4 cycles of charge in the solar system, all right, which is the bulk charge, absorption charge, flow charge, and finally equalization charge. But fortunately for those that use the lithium battery, you only have to dispense the 2 cycles of charge on the lithium battery. And the 2 cycles of charge that the lithium battery goes through is, number 1 is the bulk charge, and the second one is going to be the flow charge. So what exactly is the bulk charge? So sometimes when you use this battery overnight, when the sun goes down, depending on how you use it, you can either deplete the battery 10%, 20%, 30%, and so on and so forth. You can actually get down to as much as 80% on your lithium batteries. Now, when this is done, that becomes your battery state of charge at the moment. That's your depth of discharge. And now bulk charge takes over. That's the first guy that does the job. Okay, so that's the first cycle of charge. So it takes your battery from that DOD where you have it, which is your depth of discharge, and takes it all the way to what you call the charge voltage. So the more professional thing is to refer to it as absorption voltage. So the bulk charge takes your battery from the depth of discharge where it is at the moment and take it all the way to your charge voltage or to absorption voltage. So for most lithium battery, the absorption voltage is 56.5. So let's use, but of course you have little variations depending on the make of the lithium battery. But let's zoom in on 56.5 and use it as our charge voltage for the lithium batteries. So 56.5, that's exactly the range your charge voltage is going to be, and that's where the bulk charge is going to get headed to. So once it takes it from that 70% depth of discharge, it's going to take it all the way to 56.5. That becomes your charge voltage. So once it hits 56.5, it's going to stop charging. That's for the lithium battery. Okay, so the lithium battery does not absorb. Otherwise, it would have gone on to absorption. So once the lithium battery gets to the charge voltage, which is 56.5, it stops to charge. Then it goes back to flow charge. So what exactly is the flow charge? So the floating charge essentially is the trickle charge. So you either call it the floating charge or you call it the trickle charge. Okay, so what it essentially does is that it's just going to be floating. So it's going to regulate the energy that is coming in at this time because the battery is fully charged. The battery does not need any more energy to come in. So at this point in time, the only energy it's going to allow to get into the battery is going to be proportional to the energy that is being used at that particular point in time. Okay, so let's assume you use 5% of the battery. It's going to replace 5% of that battery. So whatever you're draining from the battery is going to allow the energy to come in. So whenever it detects a lost energy, it will replace it quickly. But sometimes the sun can go down completely. And when the sun goes down completely, you begin to drain the battery. So when the battery has been drained way beyond the float voltage, then the bulk charge kicks in again and begins to push it all the way to the charge voltage. So that's essentially how the lithium battery works. So the lithium battery goes through 2 cycles of charge out of 4. All right, so let's step over to the lead acid based batteries. And the lead acid based batteries are definitely the flooded lead acid battery, the tubular battery, the AGM battery, and the gel battery. So let's start first with the tubular battery. The tubular battery goes through the 4 cycles of charge. Bulk charge charges the tubular battery from whatever is the depth of discharge at the moment and takes it all the way to the charge voltage. So for most tubular batteries on a 48 volt system, the charge voltage is going to be around 57.6. All right, so if it's a 12 volt system, it's around 14.4. All right, so but for a 48 volt system, it's going to charge it all the way to 57.6. And for some batteries, it's going to be 58 volts. Now, when there's no more energy going into the battery, no more float, nothing, the sun is completely down, the battery is going to drop to its rest voltage, which is around 52.5. That's where you start to drain the battery. So the battery is going to drain all the way from 52.5 all the way down to 45 volts. That's for a 48 volt system. All right, so when the battery is depleted to whatever level, so the bulk charge takes the battery from whatever state it meets it, whatever DOD, and it takes it all the way to that charge voltage, which is the absorption voltage. That's the first cycle of charge gone on the tubular battery. The absorption charge takes over. So what does the absorption do? The absorption keeps the voltage at that set voltage, which is 57.6. It's going to charge the battery, keep the battery that way for the next 2 hours, 3 hours, 4 hours, depending on how much you set the charge controller or the inverter to do. You either allow the system algorithm of the charge controller to do the absorption for you, or you set the absorption time manually. So the absorption charge keeps the charging at that set voltage, which is 57.6, and charges the battery for the next 1 hour, 2 hours, 3 hours, for a very long time. Because if you're using a tubular battery or a flooded lead acid battery, the battery is not considered to be full simply because you got to the charge voltage, which is 57.6. The battery needs to stay at that level for the next 2 hours and charge. That's when the battery is considered to be fully charged. Now, when the battery is fully charged, it goes back to floating. And the floating is basically the same thing as trickle charge. Okay, so the floating is going to stay there, all right, regulating the amount of energy that comes in at this time, having in mind that the battery is fully charged. So the battery does not need to be charged anymore. So you would have little or no energy coming in. So the amount of energy the charge controller is going to be letting into the system at that particular point in time is going to be proportional to the amount of energy being dispensed by the system. So whenever it detects a lost energy, it will replace it quickly. So it's pretty much trickle charge. So if you don't call it a floating charge, you would call it trickle charge. So that's basically the float charge done. So once the float charge is done, so it's just going to be on the float charge the entire time until you definitely lose the sun, and then the battery eventually drops to the rest voltage and you begin to use it for the night. And finally, you are required to periodically equalize your battery. So if you're using a flooded lead acid battery and you're using a tubular battery, you need to understand that you have mixtures in the batteries. The solution that you have in the battery, which is your electrolyte, that's the mixture of sulfuric acid and distilled water, will begin to break down. And once it begins to break down, the sulfur in the mixture is going to leach into the negative plate and then stick in, and now weakens the ability of the battery to be able to receive charge and dispense charge, which eventually is going to culminate into battery premature failure. So you're expected to periodically equalize your battery. So what it does is essentially that equalization uses a very high voltage to charge your battery. Don't forget, I told you that the charge voltage for the tubular battery is 57.6. But if you're doing equalization, you will definitely have to raise the voltage to as much as 64 volts. And now it's a very high voltage for the 48 volt system. So if you open up the caps of the battery at that point in time, you will hear it bubbling. So it's essentially like looking at boiling water on top of the fire. You see the way it bubbles? That's the same way your battery is going to be bubbling. And when the battery is bubbling, all the mixtures and the solutions that you have in the tubular battery is going to be mixing up properly. All right, so when it mixes up, it improves the energy of the battery, so it stores more energy for you. And these are the cares, the way you need to care for your tubular battery. And that brings us to the final stage of the charge cycle. Okay, so at this point, you have completed the 4 charge cycles. So let's look at the AGMs and the gel. They are still lead acid based batteries, but they only go through 3 cycles of charge, which is the bulk charge, the absorption charge, and the float charge. So I don't think I need to start recounting again how the bulk charge, the floating charge, and of course the equalization charge happens. So for the gels and the AGM, it goes through only 3 cycles of charge. All right, the bulk charge, absorption charge, and of course the flow charge. Thank you so very much, guys. This is very much we can take today. If you haven't subscribed, please always remember that's how you support this work that we're doing, and we appreciate it so very much. Take your time to click on the subscription button. All right, don't forget to comment, don't forget to share, and do not forget to like. See you guys in the next video.